This video will cover the 2009 Math Released OGT tests, problems 36 through 40. So problem 36, a ramp is being built next to a 4-inch high sidewalk as shown in the diagram below. Which trigonometric relationship could be used to find the value of x? So there are three main trig formulas, sine, cosine, and tangent, and they all have their own specific formulas. In order to use the formulas, when you look at the right triangle, you've got to identify what's called the hypotenuse, what's called the opposite side, and what's called the adjacent. So we're going to identify those first and then talk about what formula to pick. So the hypotenuse should be the first side you try to label on the triangle. It's always across from the right angle. Even if the triangle's flipped upside down or rotated, wherever this right angle is, the hypotenuse is across from it. I always think of it as this side with the 4, that line goes through the right angle. This bottom line goes through the right angle. They're both touching it. The one across from it is the only side not touching the right angle. So this side is the hypotenuse. Then you have to look for the angle that has been given to you. They gave you the angle 10 degrees. So look for the angle that's not the 90 degrees. The right angle means 90. We want the other angle, this 10, and I'm going to do the same thing, kind of extend it. The opposite side is the one not touching the 10 degrees. The hypotenuse goes through the red angle mark I have, and the bottom line goes through. The only one not touching it is the 4, so that's the opposite side. You can also think of it as if you drew an arrow straight out from that angle, that's across. Then finally, the last side is the adjacent side. It does touch the angle itself, angle 10, but it's not the hypotenuse. So I always just do that last because it's just process of elimination. So there's a blank side. Hypotenuse has no information on it. There's the opposite side, which 4 inches was given. And there's the adjacent side where x was given, or that's telling us we would want to find. So the blank side is useless. We don't need the hypotenuse, but we have to identify it because then it makes opposite and adjacent easier to identify. So we only have opposite and adjacent. So now we go to our three trig formulas. The way I memorize these is by using so, ka, toa. Sounds like soak a toe. So if you keep that image in your mind of soaking a toe in water, that can help you remember this phrase. And what it means is the S stands for the sine function, which looks like the word sin. It's an abbreviation on the calculator. You'll see sin, but really it's sine. They just don't write the E. So sine of the angle, sometimes they just use capital A for angle, equals the opposite over hypotenuse. So with the information we were given, we have opposite and adjacent. Sine uses the opposite side and the hypotenuse side, so sine is the incorrect formula because we don't have hypotenuse. We have opposite and adjacent. So the O was where we got the opposite word, H was where we got hypotenuse. That's how it relates to this little memorization tactic. So ka, cosine, adjacent, and hypotenuse means cosine of the angle equals adjacent over hypotenuse. Again, this cannot work for us because we don't know hypotenuse. Hypotenuse is not given. We can't use this. So then we go to toa, T stands for tangent, O for opposite, A for adjacent. So tangent of the angle equals opposite over adjacent. So that's our information we have. We have opposite side, we have the adjacent side. So now we're going to fill in this information with the actual numbers. So tangent of the angle is the non-90 degree angle. Sorry, I wrote tangle because I was thinking the word angle. Tangent is just tan. Sorry about that. Okay, tangent of the angle, angle is 10 degrees, the not 90 degree piece, the other angle, equals the opposite side, that was labeled as a 4, so now we write the number 4. Adjacent side was labeled as x, so we get 4 over x. And that's all this problem wanted you to do, was end here with tangent 10 degrees equals 4 over x. The next problem, the number of hamburgers sold at a local restaurant varies inversely with the price that is charged. The number n of hamburgers sold at price p dollars can be found using the formula n equals 687.5 divided by p. So there's an important piece of information. Approximately how many hamburgers did the restaurant sell if the price of the hamburgers was $3? So, even though there's a lot to this word problem, it seems more complicated. All they're really asking you to do is give, well, the price is 3, plug it in, and simplify. So try not to let the length of the word problem freak you out. It might be really straightforward. And this one is, well, P stands for price. They gave us a price of 3. Now in the calculator, we plug in 687.5 divided by 3 is 229.1666 repeating. So you'll notice the calculator says 7 at the end. That's because the calculator automatically rounds the last digit it actually shows. Technically it is 6 forever. This one says approximately, so we're going to round at the nearest whole number because all the answers are nearest whole number. And the 1 makes the 9 stay a 9. So 229 hamburgers. Question 38. The area in square miles of the Great Lakes are shown in the bar graph. Based on the graph, which set of numbers is the closest to the total area of the 5 Great Lakes? So almost always total means to add. So we're going to add up the different amounts of the Great Lakes, but again we're estimating, so we're going to land somewhere in between these values. That's why all the answer choices say the word between. So each tick mark is another 10,000, 30,000, I'm going to say 31,000 for this. It's a little above 30,000. This one's a little above, I'm going to say 22,000 for this one, and 23,000 for this one. Lake Erie is a little bit below, probably 9,500. It's really, really close. And Lake Ontario, I'm going to say 7,500. So now we add them all together. I'm going to clear out my calculator and go 31,000 plus 22,000. 2 bar, 1 extra 0, plus 23,000, 1, 2, 3 zeros, plus 9,500, plus 7,500, 93,000. So we're somewhere between 90,000 and 100,000 square miles. When you're typing it in, just be careful. Sometimes I put an extra 0 on accident. Make sure to double check that you're doing everything correctly in the calculator. Question 39. Points R and T are the midpoints of the side of triangle QSU, as shown in the diagram below. So midpoint means they are in the middle of the triangle, or of the side of the triangle. What is the perimeter of RST? So if their midpoints from Q to R is the same as R to S, which they've shown by this little mark here, the 1 mark means from Q to R, that's the same length as R to S, and since they told us from Q to R is 14, R to S is also 14. So S to T is a 12 because T to U is a 12. They both have the 2 marks. Then the final side we need is R to T. That one's a little bit more difficult. We don't have any marks on it. But when you have 2 sides with the midpoints, this is called the mid-segment. And the mid-segment is exactly half this corresponding side. So if we do 28 divided by 2, that gives us 14. And now, to find perimeter of a shape, we add it all together. 14 plus 14 plus 12 is going to be 40. Answer choice B. Now let's say you don't remember that that's a midsegment and it's exactly half. You can't remember. If you look at the triangle itself and kind of eyeball it, you can say, well, R to T, that's pretty close to R to S and pretty close to S to T. And you can guess this is maybe 13, maybe 14, maybe it's a little more, maybe it's 15. And if you use one of those guesses just by kind of eyeballing it and still add it together, say we do the 13 plus 14 plus 12, we get 39. There's only one answer anywhere close to that. So sometimes eyeballing it can be a good tactic. You can get a pretty good estimation of what the answer should be. Last problem, the vertices of a kite are located at the points P, -2, -1, Q, -1, -2, R, -2, -5, and S, -3, -2. The image of the kite is reflected over the x-axis, and then the reflected image is translated 3 units to the right and 2 units up. In your answer document, provide the coordinates for the vertices of the final image of the kite. Provide a graph, calculations, or reasoning to explain how you determined the coordinates. So I brought up a coordinate grid and gotten rid of the calculator. We won't need it anymore on this problem. And I'm going to graph, first of all, the coordinates they gave us. P, -2, -1 means counting from the center, go left 2. -2 is an x value, and the x-axis only goes left or right, and left means negative, and then down 1. So our first coordinate is here, and that's P. Then we have -1, -2, that's Q. Then we have -2, -5, that's R. And -3, -2, that is S. So first I just created a picture of the kite itself, PQRS. And notice it looks like an actual kite, you know, an old school Mary Poppins, fly a kite in the sky type kite. So then the first part said the image of the kite is reflected over the x-axis. Reflected is basically meaning you're going to flip it or mirror it. Now there's 2 ways to do this. We could have reflected across the y-axis where it's going to pop over here, or reflect across the x-axis means it's going to flip up over here. So to do this, we say, okay, I'm going to start with one point, point P. Point P is 1 distance away from x, the x-axis. If we go that same distance past it, then we're starting the flip. So it took 1 space to get here, and then we go 1 space past, then that's our P prime. We put a little apostrophe to say this is related to the first P, but now it's different. We made a movement to it. So then Q, we go 2 spaces to the x-axis, and we have to go 2 more to get here. It's Q prime. And S takes 2 spaces to get to the x-axis, 2 more to get flipped up. And R takes 5 spaces to the x-axis, so we have to count 1, 2, 3, 4, 5, up. So there's what's called our image. This is called the pre-image, what we started with, and our image is now we made a movement. This is our new shape. So then the reflected image is translated 3 units to the right and 2 units up. Translation is just a slide. It's basically just counting. So we're going to do point by point again, but this time we're going to go 3 units right. So I'm going to start at point R this time. We're going to go 1, 2. When you hit the y-axis, that is a counting of a space. So 1 space, 2 spaces, 3 spaces. And then 2 units up, 1, 2 up, takes us here. When we make a second movement, this is now going to become our double prime. Now the blue shape is our pre-image, and what we get is going to be our image. So now we do that with each of them. Count 1, 2, 3 to the right, 1, 2, up. There's Q double prime. For P, count 1, 2, 3 to the right, 1, 2, up. P double prime. And for S, we count 1, 2, 3 to the right, 1, 2, up. And that's S double prime. Notice when we counted, I didn't say this was 1. Where I started was 0, nothing. After I moved a space counting, that was when I said 1. So where you start is not 1. You have to start at 0 and count over to be at 1 movement over. So, in your answer document, provide the coordinates for the vertices of the final image of the kite. Provide a graph, calculations, or reasoning to explain how you determine the coordinates. So this is not enough. Giving the graph is good, but it said to provide the coordinates. So, P double prime, this one here, from the center is where we always go to for our coordinates. To do our movements, it was based off the previous image. To find the coordinates, we say, well, it takes 1 right to be directly below P double prime, and 1, 2, 3 up to get to it, so this is 1, 3. To get to Q double prime, we go 2 right and 4 up. To get to S double prime, we don't go left or right, so 0 and up 4, so S double prime is 0, 4. I didn't want it to overlap, so I'm going to write it over here. And then R double prime is 1 right and 7 up. So 1, 7. So to get full points on this problem, not only include the pictures, include the actual coordinates. Always double check that last sentence and say, did I answer all the questions it wanted me to? So that concludes our discussion of the 2009 Released OGT questions 36 through 40.